Hello and welcome to a new class of EngiSmart classes. Today we are going to finish the entire topic of random variable in one video. So let's proceed. Okay, first let's discuss what is random variable. Okay, random variable. Random variable. Okay, let's discuss about random variable. Now what is a random variable? Random variable is a function that relates the elements of a sample space to real numbers. That is, let's say we have a condition of tossing two coins. Let's say tossing, first let's write the definition first. It is a function that relates the elements or the events of the sample space to real numbers. Okay, now let's say we have let's say we consider an example of tossing two coins. Okay, so what will be the sample space? Okay, now the sample space can be, let's say this is the sample space. Whenever we are tossing two coins, we can either get head and head in both the coins, head in one coin, tail in one coin, tail head, or tail tail. Now if we relate it with real numbers, then it will be called as random variable. Here random variable is denoted by x. Let's say we have the condition of let's say we are finding the probability of getting two heads. Okay, so two heads, let's say two heads. Here we have obtained two heads only once, therefore we will be obtaining two heads only once. Therefore now zero heads is also obtained once. Then one head is obtained twice. Okay, so let's say we write here zero head, one head, two head. Okay, so this can be related as, okay, so random variable will be relating the events of the sample space. So what are the different events of the sample space? The different event of the sample space are head head, head tail, tail head, tail tail, etc. And the real numbers are 0 1 2 etc. Okay, so the condition where we will get zero head, this is zero head, tail tail. When we will get tail tail, there will be zero head. Now when we will get two head will be obtained in this particular case. This is two head. Then one head will be obtained in this particular case, and one head will be obtained in this particular case. Now this will be the random variable. X is what? X is the random variable. X is what? X is the random variable. X is the random variable that will be relating the events of the sample space with real numbers. Okay, now let's discuss about the classifications of random variable. Now random variable. Okay, so random variable can be mainly classified into two categories. First is the discrete random variable, and second one is the continuous random variable. Okay, now let's discuss about discrete and continuous random variable one by one. What are discrete random variables? These are countable and these are measurable. Okay, for example, we have a sample space for tossing two coins. Let's say head head, head tail, tail head, tail, etc. Okay, so here all the conditions are measurable. Sorry, all the conditions are countable. Let's say for uh, let's say for one head is there are two, one head, two, this can be counted. For two head there will be one condition where we will be achieving two head. Then zero head, there will be one condition where we will be achieving this. Or let's say we have a sample space for rolling a dice. There will be the events in the sample space will be 1 2 3 4 5 6. So now if we say that the condition where 6 is obtained by rolling the dice, this will be 1. Okay, the condition that more than the the number that is been obtained by rolling the dice is more than 3, then this will be 4 5 6. So there will be three conditions, or there will be three conditions when and the number that is obtained after rolling a dice is more than 3. Okay, all these are countable, so these are classified in or included in discrete random variable. Now what are continuous random variable? Continuous random variable are measurable. For example, height, second, weight of students, let's say. Now again, let's say the length. All these things are measurable. So they are classified in continuous random variable. Now again, let's continue this topic. Discrete and continuous. Okay, now in case of continuous random variable, what will happen is that in case of continuous random variable, the curve that will be obtained, this is used for only example. This curve is used only for example purpose. Okay, so here we can see that the curve will be continuous. Okay, the curve will be continuous. Okay, the curve will not break at any points. There will be a continuous curve in case of continuous random variable, whereas in case of discrete random variables, it will be obtained randomly at different points. There will not be any continuous curve. Okay, now what can we calculate in case of discrete random variable? In case of discrete random variable, we will be mainly calculating, or we will mainly obtain the PMF, which is called as the probability mass function. Here we will get the expected value of x, that is the expected mean. Here we will be obtaining the CDF, that is cumulative distribution function. Then here we will be finding the variance of x. We will be finding the standard deviation. Now what will we find in case of continuous random variable? In case of continuous random variable, we will be having the PDF, that is the probability density function. Okay, probability density function. There we might have the UDF, that is uniformly distributed function. Here we can have the expected value of x. Then we have that is the mean, expected value of x, that is the mean. Then we can have the variance of x, and we can have the standard deviation. Okay, now let's discuss about the probability mass function, that is PMF. Okay, so let's discuss about the PMF. Probability mass function, which is PMF. Probability mass function, which is what? Probability mass function, which is PMF. Okay, now whenever we are discussing about probability mass function, this can be defined as a function that relates the random variables with the probability of the functions. Okay, the probability of the events or probability of the random variables. Now let's say we have the condition of tossing two coins. Okay, so here we'll be establishing the relation between random variables and random variables and probabilities, LITIS, of the probabilities of the events. Okay, now let's say we have a sample space where we are having, okay, let's say this is the sample space for tossing two coins. This is head head, head tail, tail head, tail tail. Okay, now these are the uh, random variables. Okay, random variables for 0 head, then random variable for 1 head, then sorry, this is the random variable for 1 head, this is the random variable for 2 head. Now let's write here the probabilities of the respective events. Okay, let's say this is the probability of the respective events, this is denoted by px. Okay, so the probabilities, whenever we discuss about the probabilities of one head is how much the probabilities of one head. Here in the sample space we can see that one head is obtained twice, therefore this will be 2 by 4. Okay, now probabilities of two head will be how much? Probabilities of two head will be 1 by 4, and probabilities of 0 head will be 1 by 4 as well. Okay, 2 by 4 will be 2 half. Okay, now here we write half, then 1 by 4. Okay, half, then 1 by 4. Okay, so this will be for 2 head, this will be here, for 1 head this will be like this, and for 0 head this will be like this. Again, the probability of 0 head is what? Probability of 0 head is 1 by 4. The probability of 1 head is 1 by 2. The probability of 2 head is again 1 by 4. So this will be the probability mass function, which will be called as the PMF. Okay, now let's say we have a sample space. Okay, let's say we have a sample space. Let's say this is the sample space, and these are the events. Let's say a1, a2, a3, a4, dot 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 dot, dot an, etc. And let's say these are the random variables. Let's say these are the random variables which are r1, r2, r3, dot 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 dot, dot r4, etc. Okay, now uh, now what will happen is that if we need the probability mass function, that is the probability for any particular event, then let's say this random variable r1 is associated with a1, a2 and a3, a1, a2 and a3, then the probability of x equal to r1 will be probability of a1 plus probability of a2 plus probability of a3, and so on. This will be the case. Okay, if we want to understand it in a better manner, we can see that here we are having the sample space. Let's say this is the sample space, this is head head, this is head tail, this is tail head, this is tail tail. Okay, okay, now the random variable, for what? For let's say for let's say more than at least one head. Let's say for at least one head, at least one head for at least one head, how many conditions will be there for at least one head? Here, two head, one head, one head. Okay, there will be three. Okay, so here we can see that there will be 0 head, 1 head, 2 head and 3 head. Okay, Now what will happen is that here for at least one head, how many of these probabilities or the events of the sample space are associated. For at least one head, here there will be, for two head, one head and one head, all this will be associated with at least one head, condition. Okay, so here what will happen, the probability of two head will be how much? The probability of two head will be, how much? Probability of two head will be 1 by 4. Probability of here one head, both of this will be 1 by 2. Okay, so whenever we are finding the probability mass function for, let's say, probability for at least one head will be how much? At least one head will be, this will be probability. Okay, this will be what? This will be probability for, this will be for one head, this will be for two head, this will be for one head, and this will again be for one head. So the probability for at least one head will be 1 by 4 plus 1 by 2 plus 1 by 2. Okay, now let's discuss about the expected value of x, that is E of x, which is also called as the mean. Expected value of x, which is also called as the mean. Okay, now the expected value of x for a discrete random variable will be, E of x will be summation of what? E of x will be summation of probability of x into x, that is whatever is given, we just need to add them. E of x will be how much? E of x will be let's say x1 p of x1 plus x2 p of x2 plus x3 p of x3, and so on. This will be the expected value of this will be the expected value or the mean. Okay, now this will be the expected value. Now the mean square value. Now let's study about the mean square value. Mean square value is denoted by this. Okay, the mean square value. The mean square value will be how much? The mean square value will be E of x square will be this will be summation of what? Summation of x square into p of x. X square into p of x. Thus it can be written as what? Thus it can be written as E of x square is equal to x1 square p of x1 plus x2 square or p of x2 plus x3 square p of x3, etc. This will go on. For example, let's say we are given, this is the probability mass function table. Okay, here we will be having the random variable. This is the random variable and this is the probability. Let's say this is x1, this is probability of x1, this is x2, this is the probability of x2, and this is x3, and this is the probability of x3. So we can write it like this. And remember, this is for discrete. This is for discrete. Now let's discuss about variance of x. Variance of the random variable, which will be denoted by var of x, which will be minus whole square. Therefore the variance of x can be written as the mean square value minus square of the mean. Mean square value minus the square of the mean. Okay, the variance will be denoted by sigma square. Therefore sigma square will be equal to mean square value minus square of the mean. Okay, now let's study about the standard deviation. the standard deviation. Now what will happen in case of standard deviation? Standard deviation will be denoted by sigma. Earlier in case of variance we had sigma square, therefore standard deviation will be sigma, and sigma will be equal to under root of variance. Under root of variance. Okay. Now again let's discuss about the continuous random variable. Continuous random variable. Okay, so what will happen in case of continuous random variable is that in case of continuous random variable we'll be having either PDF or PMF, PDF or UDF. Now here we'll be having PDF, UDF, etc. Now what will happen in case of PDF? What will happen in case of PDF is that this is called as the probability density function. In case of PDF we need to remember certain important concepts. So in case of PDF, whenever it is mentioned that PDF, we can apply this formula, integration from minus infinity to infinity f of x dx. Okay, so remember this formula. So whenever the limits or the range are given, so just split this infinity to infinity limit to that particular given limit, and we will be able to solve any questions that has been given in PDF. Okay, so now what will happen in case of UDF? In case of UDF, this is the uniformly distributed function. What will happen in case of UDF? In case of UDF, the slope will be constant. The slope will be constant in case of UDF. So what can we witness in case of UDF? The UDF, the diagram in case of UDF, the diagram will always be rectangular. In case of UDF, the diagram will always be rectangular, whereas in case of PDF, in PDF it can be of different shapes. Okay, now let's thoroughly discuss about UDF. In case of UDF, what will actually happen is that in case of UDF, if we plot this, okay, let's say here we will always obtain the diagram to be rectangular. Let's say this particular distance is A, then this particular distance is B. Okay, the height, this is fx, and fx will be fixed. For UDF, what will happen? For UDF, for uniformly distributed function, that is UDF, the height, that is the distance in y direction, will be fixed. In case of UDF, what will happen? In case of UDF, the distance in y direction will be fixed. Okay, so let's say, now what will be the value of fx? Now fx, now we know that the total probability is equal to 1, therefore the total area will also be equal to 1. Okay, the total area will also be equal to 1. So here what will happen is that here in case of UDF, this is rectangular, therefore base into height is equal to 1. Here base is how much? Here base is b minus a into height. Height is f of x. This will be equal to 1. Therefore in case of UDF, what will be the value of f of x? In case of UDF, the value of f of x will be how much? In case of UDF, the value of f of x will be equal to 1 by b minus a. This will be 1 by b minus a. Let's add few more slides. Okay, in case of UDF, this will be 1 by b minus a. Now let's discuss about the expected value in case of UDF. Now the expected value in case of UDF. Now the expected value in case of UDF will be A plus B by 2. So we know what is A. This is A. This is B. So in case of UDF, what will happen? The expected value or the mean will be A plus B by 2. Now what will be the mean square value in case of UDF? The mean square value, which is denoted by EX square, this will be how much? This will be A square plus B square plus AB divided by 3. This will be the mean square value. Now what will be the variance of x in case of uniformly distributed function, that is UDF? The variance of x in case of uniformly distributed function, that is UDF, will be b minus a whole square divided by 12. Okay, b minus a whole square divided by what? B minus a whole square divided by 12. Okay, this is very easy actually. Now let's discuss about PDF. Now PDF can be of different shapes. Okay, now let's discuss about PDF. PDF, which is the probability density function. Now what are we going to discuss? Now we are going to discuss about PDF, which is the probability density function. So what will happen in case of probability density function? In case of probability density function, similar to that of the PMF, this will be used for continuous random variable. This will be used for what? This will be used for continuous random variable. Sorry, this will be used for continuous random variable. Now what will be the expected value in case of the PDF? The expected value in case of PDF will be integration from minus infinity to infinity. This will be integration from minus infinity to infinity x into f of x dx. Okay, x into f of x dx. Now what will be the mean square value? Mean square value, the value that is the mean square value will be integration x square f of x dx. Now what will be the variance of x? The variance of x will be similar. This will be mean square value minus square of the mean. Mean square value minus square of the mean. And standard deviation will be how much? Standard deviation will be under root of variance. Okay, this will be how much? This will be under root of variance. Okay, now let's discuss about some important concepts regarding tossing coins. Tossing coin. Okay, now whenever we are discussing about tossing of coins, let's say this is for tossing of 2 coins. Sorry for the inconvenience. Tossing of 2 coins. Now we are discussing about what? Now we are discussing about the tossing of 2 coins. Now whenever we are discussing about the tossing of 2 coins, what will happen if we are asked to find the if we are asked about the sum of let's let's say we are asked about this okay, let's say we are asked about dices. Actually, let's say we are asked about dices. Sorry, that was my fault. Let's say we are asked about the dices. Now let's say 2 dices are rolled. Okay, and we are asked about the sum of the numbers that occurs in both the faces. Now what will happen is that the expected value or the mean in that particular case will be n into 7 by 2. Expected value will be what? Expected value will be n into 7 by 2, where n is the number of times the dice is thrown, and the variance of x will be how much? And the variance of x will be n into 35 divided by 12. Okay, these are some of the important formulas. So if we remember this will be very easy for us to solve any questions based on this. Okay, let's discuss one question. Actually, let's discuss one question. Let's say, oh sorry, this is the question which was asked in case. Now what is the question? The question states that throwing two dice, the expected value and variance for sum of the numbers on the dice are the options are given as 7 comma 35 by 6, option B this is 7 by 2 comma 35 by 12, option C it is 7 comma 35 by 2, and option D it is what? It is 7 by 2 comma 35 divided by 6. Okay, so let's solve this. This was asked in GIFT. Okay, so here we can see that throwing two dice, so n will be 2, the number of times a dice is thrown, or the number of dice that are thrown at the same time are same, both the cases are same. So here the number of throws will be 2. So what will happen here is that throwing two dice and the expected value will be what? We know that the expected value, formula for expected value is n into 7 by 2. Here it is thrown twice, therefore 2 into 7 by 2, therefore the expected value will be 7. Now what will be the variance? It is thrown twice. We know that the formula for variance is n into 35 divided by 12. Now what will be the value? 2 into 35 divided by 12 to 6. This will be 35 by 6. So what will be the answer? 7 and 35 by 6. This is one, option A. Answer is A. Okay, this is that easy. Now let's discuss about some of the important properties of mean and variance. Some important properties of mean and variance. Some of the important properties of what? Some of the important properties of mean and variance. Okay, let's discuss about some of the important properties of what? Some of the important properties of mean and variance. Okay, the first important property is what? Sorry for the inconvenience. The first important property is what? The expected value of a constant will be the constant itself. That is, let's say we are finding the expected value of 10, then it will be 10 itself. Okay, now the second point will be the expected value of a into x will be a into expected value of x. Okay, now third important formula or concept is expected value of ax plus minus by will be what? This will be a expected value of x plus minus b expected value of y. Okay, this will be a expected value of x plus minus b expected value of y. Okay, now if we discuss about variance, what will happen? We know that the variance is what? Variance of x is the mean square value minus the square of the mean square value minus the square of the mean. Okay, so whenever we discuss about the variance, what will happen is that if we try to find the variance of a constant, what will happen? This will be the expected value of that square of the value of that constant, and this will be the mean square of the mean of that particular constant. So what will happen? This constant will come out, this will be constant only, and here this will be constant, hence it will be equal to 0. Thus what we have obtained is that, so it was fourth property. So the variance of a constant is equal to 0. The variance of a constant is equal to 0. Now the fifth one is the variance of a into x is equal to a square into variance of x. Now the variance of ax plus minus by is equal to a square variance of x plus b square variance of y plus minus 2ab 2ab covariance of x comma y. Let's say this is x and this is y, where x and y are what? X and y are random variables. Okay, x and y are random variables. Now what do you mean by covariance? Covariance of x comma y. Here x and y are random variables. Now covariance means that if there is simultaneous variation of both the random variables x and y, then it is called as the covariance of x comma y. Then it is called as what? Then it is called as the covariance of x comma y. Okay, let me add few more slides, then we will again proceed. Okay, now so what will be the formula of covariance? The formula of covariance will be what? The formula of covariance of x comma y, where x and y are two random variables. This will be expected value of xy minus expected value of x into expected value of y. Okay, now then an important condition: if x and y are two independent random variables. Now if x and y are two independent random variables, then what will happen? Now in terms of probability, we know that if we are finding the probability of a intersection b, and if a and b are two independent events, then we had the probability, it will be probability of a intersection b is equal to probability of a into probability of b. Okay, probability of a into probability of b. Now so similar case will happen in case of expected value as well. Expected value of x comma y, expected value of xy will be equal to expected value of x into expected value of y if x and y are two independent events, two independent random variables, So what will happen to covariance? Covariance of x comma y will be equal to 0 if x and y are two independent random variables, then simultaneous variation of both x and y cannot take place. Hence, what will happen? Simultaneous variation of both x and y cannot take place. Simultaneous variation of both x and y, what? Simultaneous variation of both x and y cannot take place. Hence, what will happen is that, hence we can say that the covariance of x comma y will be equal to 0. This is because we know that the formula of covariance of x comma y is what? Covariance of x comma y is expected value of xy minus expected value of x into expected value of y. So what will happen here is that this will be expected value of x into expected value of y minus expected value of x into expected value of y. Thus it will be equal to 0. Thus in case of covariance of x comma y, where x and y are two independent random variables, it will be equal to 0. Okay, these are all the important properties. Now let's discuss about the exponential distribution. Exponential distribution. Now let's discuss about the exponential distribution. Now let's discuss about the exponential distribution. Here the function will be like this. Here we'll be having lambda e to the power minus of lambda into x for all x greater than equal to 0, x greater than equal to 0, and it will be 0 otherwise. Here lambda is what? Here lambda is the rate parameter. Here lambda is what? Here lambda is the rate parameter, and mean is what? And mean is 1 by lambda. And mean is what? And mean is 1 by lambda. Now what will we do? In what cases the exponential distribution will be used? The exponential distribution will be used in the questions where we need to find the lifetime or the average lifetime. Whenever we are asked to find the lifetime or the average lifetime in such questions, this exponential distribution will be used. In such questions, the exponent e will be present in the question itself. Okay, now what will be the probability? Total probability for exponential distribution. Total probability or total probability is equal to area. Total probability is equal to area, and it will be integration from 0 to infinity. Remember that it is from 0 to infinity f of x dx. It will be from 0 to infinity f of x dx. Okay, that's all. Okay, now let's discuss a question based on exponential distribution. Now what is the question? The question was asked in GATE 2007 by IIT KGP. Okay, now let's discuss the question. The question states that the exponential distribution function is given as f of x is equal to how much? F of x is equal to 1 by 5 e to the power minus of x by 5. Okay, minus of x by 5, where when x is greater than equal to 0, now we are asked to find the probability that it will exceed 5 minutes. Probability that it will exceed 5 minutes. Okay, probability that it will exceed 5 minutes. Now what do we know about exponential distribution? We know that the exponential distribution here f of x is equal to lambda e to the power minus of lambda into x. Okay, so by comparing we can see that here lambda is equal to 1 by 5, therefore rate parameter is equal to 1 by 5. Okay, the rate parameter is equal to 1 by 5, and mean is equal to how much, and mean is equal to 1 by lambda, therefore mean is equal to 5. Okay, mean is equal to 5 minutes. Now what we can see that in case of exponential distribution, the total probability is equal to integration from 0 to infinity f of x dx, but we are asked for probability that it exceeds 5 minutes. It exceeds 5 minutes, thus it will be from 5 to infinity f of x dx, thus it will be from 5 to infinity. What was the function? The function was given to be 1 by 5 e to the power minus of x by 5. Okay, e to the power minus of x by 5. So 1 by 5 will come out. This will be integration from 5 to infinity e to the power minus of x by 5 of dx minus the dx. Okay, this will be 1 by 5. Now integration of e to the power minus of x by 5 will be e to the power minus of x by 5, minus will come out, and it will be 1 by 5. This will go from 5 to infinity. So what will be its value? This will be 1 by 5, minus sign will come out. Okay, this will go up, and it will be 5. Then we'll be having, by putting the limits, what will happen? Putting the limits, we will be having e to the power minus of infinity minus of infinity minus of e to the power minus of 5 by 5. Okay, minus of 5 by 5. So this will get cancelled out, so, and this will get cancelled out. So finally what will happen? This minus and this minus will get finally cancelled out, because e to the power minus infinity is 0. So the final answer will be e to the power minus 1, which will be equal to 1 by e, Okay, so that's all. Thank you for staying till the end. So with this we will like to wrap up random variables. Thank you.